Doing a video lesson for today's notes and homework since I'm out today, and we're talking about composition of transformations. So this is combining the transformations, translations, reflections, rotations, and dilations that we have done last week. We're now putting them all together and doing multiple transformations at a time. So this little example with this illustration with this foot, it's taking a translation and then it's reflecting. So it's two transformations, one after another. Feel free to pause at any time throughout the video if you think I'm going too fast, need to jot some stuff down as you guys are filling in your skeleton notes and working along. So first, we've got two transformations. They first want us to rotate 180 and then reflect over the y-axis. So it's two different ones. So the best way for me to do this is to write down these coordinates, K, L, and M, and then perform the first transformation, which would be rotate. And if you recall, that is to change the X and Y, do the opposite of X and Y when you rotate 180 degrees. So that's going to be -4, 1, -5, 2, and -1, 4. Then the next transformation is to reflect across the y-axis, and if you recall, the rule on that is to take your X and change the sign on it, but leave the Y the same, which would be 4, 1, 5, 2, 1, 4. So to plot those, I would go to 4, 1, that will be my new K. We'll go to 5, 2 will be my new L, and 1, 4 will be my new M. Okay, so in order to get there, we would take this object and we would rotate it 180, which we get it up here somewheres, and then we're reflecting over the Y, and that gets it over here. Next, we are doing a reflection over the Y, then rotating 180. And again, this is going to be easiest done by doing your coordinates. Now, you might be able to eyeball your reflection over here, and then your rotation is going to put it up here somewhere. Okay, but it's going to be really hard to do this without using your coordinates. So I'm going to first write down my coordinates. So X is -3, -13, Y is -6, -7, and then Z is -12, -10. So to reflect over the y-axis, I'm going to just change the opposite sign on the x coordinate. So that gives me 3, 13, 6, oh, keep the 13 negative, -7, and 12, -10. So trying to move quickly here. Again, feel free to pause. And then our last one is to rotate 180. And then whenever we do that, we want to change the sign on both of them. So I would then go to -3, 13, -6, 7, -12, 10. And those are going to be my final transformation. So that is -3, then 13 should be up here, and that's going to be my, let's see, new x. And I'm going to have -6, +7, should be right there, my new y, and then -12, +10, right there. It's my new z. Connect the dots. And there we go. Next up, we have reflection across the line x equals -2, which I can draw out for us. It's an excited vertical line. Then we're going to translate with a shift of right 1 and up 16. So this one I think is easiest to count up your distances from the line of reflection. So if I count up these distances right here, I'm going to get 6 and 2, that's 8 units, and then 9 and 2, that distance is going to be 11, and that distance is going to be 11. And I'm going to reflect those and go out 11 units in this direction. So that'd be 2 and 11 would give me -13. And then the same thing down here, -13. And then this one would be 3 less, which would be 10, -10. All right, and that would be my new, well, not my final t, but my intermediate t, u, and v. We can put 1 mark. Then we need to perform our translation of right 1 and up 16. So if I'm at -11 and I go up 16, that'd be 11, and then 5 more would get me to 5. And this one's at -8, so I'm going to go up 8 and then 8 more for 16. Oh, and I need to go over 1. Should be right there. And then this one is at 14, so I'm going to go up 6 and then 2 and right 1. So my final transformation, and I'll put 2 prime marks, would be right there. So that's a reflection over that line, x equals -2, and then a translation of 1 unit right, 16 units up. All right, now we've got to rotate 90 degrees counterclockwise and then reflect across the y. So on these rotations, I think it's much easier to write down my reflections. If I'm going counterclockwise, then that should put this up here somewhere, and then reflect. This final answer should end up over here somewhere, just to give me an idea of where I'm going. So let's write down my original x point, which is 2, -5, w, which is 10, -5, v, which is 10, -9, and y, which is 2, -9. So the rule to go 90 degrees counterclockwise, which would be a positive 90 degrees, we want to take our xy and we want to do -yx of that. That's for 90 degrees positive. So that's going to give me, if I just write down this x column in the second space of my ordered pair, that's going to give me 2, 10, 10, 2. And if I do the opposite of the y over here, that gives me 5, 5, 9, 9. And then to perform the final or second translation, I'm going to reflect over the y, and the rule on that is to simply change the sign of your x coordinate, which would give me -5, 2, -5, 10, -9, 10, and -9, 2. So let's graph those. So if I go over 5 up 2, that's going to be my new x. I'm going to go over 5 up 10 to get my new w. Over 9 and up 2 for y. Over 9 up 2 for b. And there we go. All right. That's about got us wrapped up. So here's just kind of some summary here, just showing you what's going on, that it reflects and then reflects again. If you're going over 2 lines, if you do 2 reflection of intersecting line, it's the same as doing a rotation. Probably won't have to use these facts as we go through our assignment. All right, so let's go on to our assignment now. So we're going to go look at our Khan Academies. The first one I have for you is find measures using rigid transformations. So this one actually is a review, and it is showing that size and angles are preserved with a rigid transformation. So if I rotate, it's a rotation, that's a rigid transformation. These angles stay the same, and these sides stay the same. So what's the perimeter? Well, if this is 5.1 and 5.8, and this is 5.8, this is also going to be 5.1. And this is also going to be 2. So you just add those up. The perimeters are going to stay the same when you rotate. So 5.8 plus 5.8 would be 10.9. Plus 2 would be 12.9. So that one will be 12.9. Correct. Let's do one more of those. What is the segment length? Well, these angles are all the same. That will be helpful on other questions. So all 3 of these angles are the same. 75, 46. Use your 180 rule to find the missing third angle. But this will be the sides of 8, 6, and 9. So if this one's 8, the translated one preserves congruency. It will also be 8. Correct. All right. Next up, also looking at rigid transformations. This one's a little bit tougher. I want you to try to get at least 75% on this one if you can. If we rotated this quadrilateral 60 degrees about the origin, so that would look something like putting it over here somewhere, just moving it over 60 degrees. Which of these are true? Well, it's going to be the same size. So are they both parallel to the y-axis? Well, BC is parallel, but if I shift it, no, it will not be parallel, so that's not true. Are they same measure? Yeah, the angle, these angles won't change. They're going to be the same. Are the point D and D prime going to be the same? No. So the only one that's the same is B. And that's mostly what you're going to be looking for on all these. Now a circle, let's see here. The circle would stay the same if we reflected it. We just have us another circle over here somewhere, which would be our new circle A. What do we know about that? The radius is the same? Yes. They have the same circumference? Yes. The size doesn't change. They have the same area? Yes. All the above. Choose all the answers. Okay, so we got to check them all. They all are true. One more of these. Let's see. If we translate this 5 and 5, so we're going to go over 5, up 5. So this object would move over here somewhere. Oh no, it's going down rather. 5 units to the left. Okay, so actually we'd go this way and down. So we'd move it down here somewhere. Okay. Which of these would be true? Well, same measure. Yep. Area's the same. Yep. Perimeter's the same. Yep. So actually all that's going to be true because it doesn't change those facts. They're still congruent. All right, that gives you a good idea how to do these. We'll keep moving on. All right, now these are fun. About as much fun as you can have on Khan Academy, which I actually personally enjoy. So what you're going to do on these is you need to carry out these transformations that will put these two shapes on each other and then determine if they're congruent. So I always start with translate. So I'm going to translate and I'm going to try to put this blue one over on G. Now it almost looks like they're ready to go, so I either need to rotate or reflect. It looks like if I rotate this around, it actually put the dot right where I need it, but you can move this around. We'll put the dot right there on it, and then I'm going to hold this little arrow and move it around. Now, are those two objects congruent? No, because one angle doesn't match, so they're actually not congruent, and you have to line them up before you can tell that. All right, let's do one more of those. So I'm going to take this blue shape and I need to try to get it on the red shape. So I like to translate first. Come down here and translate. It's close. Then I can either reflect or rotate. Here I'll show you a reflection. Oh, it put it right where I need it. So you can actually, on reflections, you can actually drag this line wherever you need it. Okay, and then you click the arrow and it flops it over there. You can actually rotate this, but it put it over there where I need it. Now, if you look at that, let's see if we can drag this arrow around. They almost look symmetrical. Let's see if I flip it. Oh, there we go. So I had to do 2 reflections. You could also do a rotation and achieve the same result. They are right on top of each other, so I know they are in fact congruent. Now a hint, as you do these, if it takes you more than 3 transformations, you're probably doing it wrong and it's going to get off. It'll get just off enough that the computer can't tell the correct answer and you'll get it incorrect. Okay, so if you have to do more than 3 or 4 transformations, you're not doing something right. And then the last one is the same thing, except it's going to add dilation. So these are actually going to be similar, which means same shape, different size. So get the blue one onto the red one. Again, I like to go translate first. It looks like B and E correspond. So I'm going to do that. Then I'm going to rotate. So for rotate, wherever I put this point is where I'm going to rotate from. And then I'm going to grab the arrow and rotate it where it goes. And then I need to dilate from that same point. So I'll put my arrow up point there, stretch it out. They don't quite match up, do they? So I'm going to say this is not similar. Let me undo all these just to make sure. Let's see. But yeah, seems to be off just a little bit. So I'm going to say they're not similar. And they were not. So they should line up just perfectly if they are. So on these, they look close to the same. So again, I like to go translate first. Get it right on there. Then I'm going to go rotate. and put my dot right on that point. Click the round arrow, move it around. These are looking like they're going to be similar. I'm going to put my dilation. Boom. Grab the outside arrow, stretch it till they line up perfectly. Yes, they are similar. And that's your last one.